Hello and welcome to today's webinar titled Progress Towards a Climate Resilient Built Environment. My name is Suzanne Sealing. I'm with the Climate Risk Institute and I will be the moderator for today's webinar. If you run into audio or technical issues during the webinar, please hover your mouse over Suzanne Sealing's name in the attendee list under Host and click on Start Private Chat. Please note that your lines have been automatically muted to avoid any audio distractions or feedback during the webinar. There is a dedicated Q&A session at the end, but that doesn't mean you have to hold your questions until then. Please feel free to type out your questions during the presentation in the chat box area. We are recording the webinar today and we'll be sending out a link to everyone who is registered. It will also be posted on CRI, the Climate Risk Institute's website. A link for that will be provided at the end of the presentation. Now I'd like to introduce our speakers for today's webinar. First, we have Marianne Armstrong. Marianne is Director of Stakeholder Engagement and Management with Canada's National Research Council Construction Research Centre. In her current role, she is managing research in support of provincial and territorial priorities for building codes, as well as engaging key stakeholders in the transformation of the current national code system. From 2016 to 2019, she managed the Climate Resilient Buildings and Core Public Infrastructure Initiative to integrate climate resiliency into Canadian building and infrastructure code standards and guidelines. For over a decade, Ms. Armstrong also conducted residential energy efficiency research at the Canadian Centre for Housing Technology, where she helped to assess the performance of over 60 different housing technologies. Ms. Armstrong is a member of the Professional Engineers of Ontario, holds a Master's of Science in Industrial Design from the University of New South Wales, Sydney, and a Bachelor of Science in Mechanical Engineering from Queen's University. Our next presenter is Chad Nelson. Chad serves as the Principal Advisor for Climate Resilience and Natural Infrastructure at Infrastructure Canada. Since 2016, he has led a team that tackles key program and policy initiatives, including INFC's Climate Lens funding requirement, various funding programs, and domestic and international engagement. In this role, he has been responsible for oversight of the National Research Council-led Climate Resilient Buildings and Core Public Infrastructure Initiative that received $42.5 million in funding from Infrastructure Canada. Previously, Chad held policy and applied research positions at Environment and Climate Change Canada, Health Canada, Fisheries and Oceans. He has worked across 5 provinces for provincial and local governments and think tanks, including at the former National Roundtable on the Environment and Economy and the International Institute for Sustainable Development. He has an MA in Community and Regional Planning from UBC and a BA from Trent University. On behalf of everyone joining us today, I'd like to extend a warm welcome to Marianne and Chad for presenting this webinar for us today. It's very much appreciated. And so without further ado, I will now turn things over to you, Chad.
Wonderful, thank you. Can you hear me okay, Suzanne?
Yep.
Wonderful. Well, thank you, Suzanne, for those kind introductions. Thanks also to Natural Resources Canada for sponsoring this webinar, and to Suzanne and the Climate Risk Institute for coordinating it. First, welcome and thank you to all of you for joining us from across Canada and perhaps beyond. We were thrilled to receive about 400 registration requests. Second, as to structure, I'll provide a few opening remarks momentarily to set the stage for our main presenter today, Marianne Armstrong. Third, for the question and answer session, we look forward to receiving your written questions through the chat function. I would note, as Suzanne did, that the participant lines are muted given the high turnout. S'il vous plaît, posez vos questions et partagez vos commentaires, bien sûr, dans la langue officielle de votre choix. Toutefois, cette présentation se déroulera en anglais. Finally, I am participating from Ottawa, and I would like to begin by acknowledging that the land on which I am speaking from is the traditional unceded, unsurrendered territory of the Anishinaabe Algonquin people. The Algonquin peoples have lived on this land since time immemorial, and I am grateful to have the opportunity to be present in this territory. And now, for my other opening words. I'll just advance the slide. Climate change. It is a significant, if not an existential challenge. This is reflected by global scientific reports and high-level global agreements to take action, but also in Canada by the over 500 municipal governments that have declared it to be an emergency. Canada's climate is warming at double the global average and about triple in our north. In fact, we've already experienced a changing climate. Canada's average annual temperature over land has warmed 1.7 degrees Celsius between 1948 and 2016, while the average winter temperature has increased more so by 3.3 degrees Celsius over the same 60-year period. Although not uniform, that's much more dramatic than the average warming around the world of between 0.8 degrees Celsius and 1.2 degrees. Notably, 7 of the 10 warmest years of recorded global average temperature have been the last 7 years. Looking ahead, scenarios of global greenhouse gas emissions project greater warming. In fact, compared to the recent past, 1986 to 2005, the average annual temperature in Canada is projected to increase between 1.8 degrees Celsius and, if emissions are not curtailed, by up to 6.3 degrees Celsius by the end of the century. This means that in a span of 150 years, 1950 to 2100, we could experience a comparable increase in global temperature as to what we have experienced since the last ice age 5,000 years ago, of 4 to 7 degrees and change. A changing climate presents a wide range of challenges for our communities and public infrastructure. I think some of the pictures on this slide do a reasonable job of illustrating that. When thinking of public infrastructure, this includes transportation, energy and communications, water systems, buildings, recreational facilities, and increasingly recognition of natural infrastructure. Specific examples are roads, bridges, water, wastewater treatment plants, electrical transmission lines, light rail transit and subways. Impacts and consequences of climate change are also projected to be wide-ranging, meaning increasing extreme heat, drought, wildfire, sea level rise, permafrost thaw, flooding, and that's really inland, we think of rivers and fluvial, or urban, we think of rainfall and pluvial, and also coastal flooding, as well as storm surges and coastal erosion. Along with the increasing frequency and severity of natural hazards associated with climate change, there's overall greater variability. Some like to call this, in fact, climate weirding. And you think of jet streams slowing down and shifting, and the polar vortex, well, and ice fishing in Texas. The 2019 report by the Council of Canadian Academies expert panel on climate risks identified physical infrastructure as one of the sectors in Canada most at risk from climate change impacts, but also a domain in which there is great potential to reduce consequences of climate impacts. This is particularly important when thinking of the $1.9 billion in annual costs of climate impacts over the last 10 years as cited by the Insurance Bureau of Canada. There have also been studies by the Federation of Canadian Municipalities saying that up to $5 billion roughly annually could be spent by all levels of government to avoid the worst impacts of climate change. Current approaches used for design and rehabilitation of Canada's infrastructure are largely based on historical climate data and loads, and thus do not fully represent what we will experience in our future and warmer climate. I'd also add, because this is particularly important when we think about the Canada Infrastructure Report Card, citing a third of municipal infrastructure in fair to poor repair or needing upgrades. I'd like to now advance to my next slide, and I don't have too many before we get to the main speaker. But there's been a great deal of recognition growing for the need to adapt, need for adaptation and climate resilience of our infrastructure. And it's been growing by leaps and bounds, both in Canada and abroad. Globally, this is evidenced through mounting initiatives, many of which link to data, guidance, standards, and building codes. This past January alone, we had the Global Climate Adaptation Summit with heads of state participating, followed by the release of the 16th Annual Global Risks Report of the World Economic Forum, which is a survey of about 800 leading CEOs that cited extreme weather events with major damage to property, infrastructure, and loss of human life as a topmost threat. We also saw a release in January of the World Bank's new resilience rating system for infrastructure. This was followed then in February by release of the European Union's climate adaptation strategy that spoke to infrastructure standards and codes and guidance. And also 10 days ago, the annual meeting and then a 3-day conference of the Global Coalition for Disaster Resilient Infrastructure, led by India, with many other countries participating, which is a global knowledge exchange platform. And incidentally, the coalition's work is aligned with the Global Resiliency Dialogue that's being advanced by the International Codes Commission. And Marianne represented Canada at a founding meeting of this initiative. In Canada, though, we saw just last week the Canadian Construction Association releasing a press release and a report calling for greater investments in climate resilient infrastructure. And the Government of Canada is recognizing the importance of adaptation and is taking action through launching a national infrastructure assessment, which includes consideration of climate resiliency, developing a national adaptation strategy, and a national risk profile and associated flood mapping. Infrastructure Canada is making significant investments in long-lived public infrastructure and has implemented a climate lens to foster integration of climate resilience. And in the face of the pandemic, I think we all see that every dollar must do triple duty, in essence, creating jobs, stimulating the economy, supporting our communities, and fostering green decisions, meaning investments that reduce greenhouse gas emissions and manage climate risks. The foundational work led by the National Research Council of Canada from 2016 through to the day after tomorrow is key to ensuring that Canada's public infrastructure will better face the impacts of climate change. Through the Climate Resilient Buildings and Core Public Infrastructure Initiative, public infrastructure decisions about location, design and build, planned operation and maintenance can now better protect people and communities and reduce the total costs of asset ownership. This work has spanned many types of infrastructure assets and many types of climate impacts and natural hazards to set a foundation for continued progress. Today we will hear about this world-leading work that spans future climate design data, guidelines, standards, and codes to stop us from designing for a past that no longer exists. Rather, today's long-lived investment decisions need to ensure that existing and ongoing climate change and associated extreme weather events are considered. I do ask of today's participants to seize the knowledge from this webinar and other related initiatives and engage in their local and professional communities, as we can no longer make decisions rooted simply in past understandings of climate design data, guidance, and standards. In essence, we can no longer drive forward staring in the rearview mirror. One of the mechanisms that we have for discussing and advancing adaptation resilience is an infrastructure and buildings working group under the Natural Resources Canada-led Adaptation Platform. I have the privilege of co-chairing this group. This slide is in this presentation, but I'll suggest we skip over it in the interest of time. But if people are interested to know more, they're welcome to contact me. I'll now turn to Marianne Armstrong, with whom it has been a true privilege to work, along with her colleague Fiona Hill, over the last 5 years on this impressive initiative. This is where I think I would normally ask for a round of applause to welcome her to the podium, but we're all working in a new normal, and at least today, I did decide to wear socks for this webinar. Welcome, Marianne.
Thanks very much, Chad, and thank you for that introduction that really places this work in its importance for Canada, but also internationally. And I echo that it's been a real privilege to be able to undertake this work with funding from Infrastructure Canada and to be here today with over 200 participants. Wow, that's really rather amazing. And it's wonderful to see, to be able to tell you about the results of the work we've been doing for the last 5 years. So thank you to Suzanne with the Climate Risk Institute, as well as NRCan and Infrastructure Canada for making this possible. So I'm going to dive in right away and get talking about some of the tools, some of the outputs, some of the outcomes from our work that I really hope that you can walk away from this webinar with the feeling that, wow, yes, I could really use that information. Look at ways you can integrate it in your own work. Look at who else could find this useful in what they're doing so that we can really build what I like to think of as a culture of resiliency in this country. As part of this work, we really generated the foundation of science and information that's needed to make our infrastructure and our buildings more resilient to climate change and extreme events. But it's only one piece of the puzzle, and I think that's important to recognize. We all need to work together to achieve adaptation and a state of resilience in Canada. So we undertook this project. We started about 5 years ago with the goal of integrating climate resiliency into codes and standards in a number of different areas. 5 different asset areas at the time were chosen. So we picked out roads, buildings, bridges, water, wastewater, as well as transit. So as a result of this, we've managed to advance the field in all these different areas, and it's really a pleasure today to be able to tell you about what we've achieved. So it wasn't just NRC working alone, of course, working with Infrastructure Canada, but we also had over 200 different collaborators on this work from all walks of life, climate scientists, engineers, consultants, universities, experts right across the board. It's really a multidisciplinary challenge of making this happen. And many of those collaborators volunteered their hours on a lot of our committees to enable us to develop guidance that's usable across the country. So as well, of course, with NRC, we were able to mobilize our expertise, again, working cross-discipline. We had our infrastructure and our building scientists. We had our coastal and river engineering folks helping us on the flooding side, as well with hydrology. We even had our aerospace engineers involved working on vibration of bridge cables and wind dynamics. And finally, we also host the National Model Building Code at NRC. So it was really drawing on multiple areas of NRC's expertise to this very big problem. So where we stand today, 5 years later, I'm proud to say that we have significantly advanced the field of climate change adaptation for buildings and infrastructure. And there's a lot of ways we're at the leading edge of this effort internationally. We're the first ones looking to develop and integrate future-looking climate data into our codes and standards. So it's really quite amazing, rather. I've been on the sidelines orchestrating a lot of it, but not the one doing the work, and there's been major inroads made. And also, as we sit here 2 days till the end of the project, by the end of the project, we'll have developed a suite of evidence-based guidance documents on how to adapt for the different infrastructure areas. Now, I make that promise, but the reality is we still have to translate and publish a number of these items, so they might be finished in draft form 2 days from today, but give us a few months to get the information out there. So whatever you hear about today, please check our website in a couple of months. Hopefully, we hope to have the majority of it out and available. Okay, to remember how to change slides. There we go. So in this presentation today, I'll be running through a number of different areas that we've advanced. The first one is climate design data. The second one will be looking at flooding, then wildfire, updates to the electrical code, and finally what we've done in all 5 of those different infrastructure assets: buildings, bridges, water, wastewater, roads, and rail transit. Additionally, we can't really do adaptation without considering mitigation, so I'll speak a little bit to the work we've done more specifically on life cycle environmental assessment in a changing climate. And then I want to end on where we're at today, what new capabilities we have that we didn't have 5 years ago, and also where I think we need to go next. So the very first item I want to talk about is our future climate design data. So when we first started out on this road, we realized in order to design for the future, we needed to know what the future of Canada looked like. And it wasn't good enough just to get a sense of what the data is that we could use. We actually needed very specific data to meet the needs of our engineers who were designing buildings and infrastructure. So we worked very closely with Environment and Climate Change Canada. I note that Alex Cannon is on this call. He was very instrumental in making that happen, as well as Pacific Climate Impacts Consortium. So together with them and with our engineering friends, we put them all together and came up with the design data that's needed for engineers and needed by the building code as well as the bridge code. And I'm happy to say that this is published and available at the link here, shown here, and I'll give you a snippet of exactly what that looks like in a second. So if you do click on that link or visit that website, and hopefully we've made the slides available to you either now or after, so you'll be able to go visit that site. I invite you to have a look at the report, lots of details in there. We're actually coming out with a more user-friendly guidance to go along with that, to boil it down a little bit more away from the climate science and the engineering pieces to make it a little bit more user-friendly. So we hope to have that out shortly as well. But in terms of key findings, comes as no surprise how Canada is changing. Temperatures are going up. As Chad mentioned, we're warming at twice the global rate, if not more, especially in the north. Our extreme highs, so warm summers, cold winters, also warming up. Precipitation's on the rise because warm air holds more moisture, but it doesn't fall evenly right across the board, of course. One-day rain is going up as we see more convective cells and large dumps of rain. Wind pressure generally is going up too, but there's a lot of uncertainty in that actually because it's harder to understand what wind's going to look like in the future, as we discovered working with the climate scientists. Snow and ice generally are going down, except in the north. Snow cover duration going down as I look outside in March, and there's very little snow to be seen here in Ottawa. That's perhaps an example of us seeing the change. And permafrost temperatures as well are going up. So none of this is really surprising. But what's quite unique about this data set, there's a few things. One thing is that we've linked these changes to degrees of global warming. So Alex and his friends over Environment Canada came up with how Canada is going to look in terms of rain, temperature, for different degrees of global warming, from 0.5 degrees right up to 3.5. And this is unique in that it decouples the climate data from the climate scenario. So this way you can look at, assume you want to design for RCP 8.5 and say, okay, well, in 50 years with RCP 8.5, I expect X degrees of global warming. So this is how Canada is going to look. So this way, when we start designing, we have to look at how long my asset's going to last, which scenario I want to design for, and that will give us a link into this climate data set as to what degree of global warming I'm designing for. So some examples are shown here in terms of annual changes in rain on the left side, total precipitation in the middle, annual temperature on the right. And you'll notice one of the other unique things about this data set is that for each set of, I would say each climate data or type of climate data, we've also included some level of uncertainty. So this comes from having a 50-member ensemble, a run of CAN RCM4 for those of you who are in the speak. So they ran the regional climate model 50 times, and they capture both the 25th percentile and the 75th percentile of the run. And that gives you some level of uncertainty. So that's the broader bands you see on the rain, the tighter bands on the temperature, because it's a little bit more certain where we're headed. And you can imagine I didn't include wind here, but wind is very, very broad in terms of the uncertainty. So that being said as well, they developed specific data for 660 locations. These are locations referenced in the building code. We have all the numbers needed for all the data in the building code, as well as a highway bridge design code. So very unique set of data. I invite you please to go check it out, learn more about it. If you have any questions, happy to answer it. And ultimately, we're looking now to work with the building code to introduce this data, as well as a highway bridge design code. So with that basis of climate data, I think the next thing we needed to do is look at where some of the bigger gaps were in this country. And of course, we're all familiar with flooding and wildfire being two of the most major issues being faced by Canada, especially in terms of dollar signs, insured losses, losses that aren't insured. So a number of outputs from our work really focused on flooding. So one thing I get asked once in a while is, what are we doing for climate data for flooding? For example, IDF curves, which are intensity, duration, and frequency curves, which are used to design stormwater systems, flooding infrastructure. So we're actually working right now with Pacific Climate Impact Consortium to develop future-looking IDF curves. So that is in the process of coming out shortly. We're just finishing up now, so that will become available in the next couple of months too. So that's a major it's a very important item for the flooding sector. So other areas that we've been working in flooding include one of our very first publications from our work. We worked with Intact Centre and Standards Council of Canada to come up with best practices for flood risk reduction in existing residential communities. So that publication, there's a link to it here, is called Weathering the Storm. And what's nice about that publication too is now it's become a seed document for the CSA standard W20, which is a brand new standard that's coming out W210. So it's actually right now out for public review, and you can review it up until April 10th. So I invite you to look that one up if you're interested in looking at it or providing feedback. It's up for public review. With CSA as well, we've worked on a number of standards related to flooding, 2 on bioretention systems, 1 on basement flood protection and risk reduction for residential basements, and also 1 on climate change adaptation of wastewater treatment plants. And that's quite a unique one, the wastewater treatment plant one, in that we're starting to look at climate change adaptation of specific assets. And we would look to the future. I think this is really where we're headed, is to develop guidance that's applicable more specifically, say, to healthcare infrastructure or transit infrastructure or wastewater infrastructure. So I think that's perhaps where we're headed with this work. The last item here is kind of neat. You can see a picture of it on the right. It's a new technology called a buoyant foundation technology with Elizabeth English out of University of Waterloo. They developed and built this particular prototype at University of Waterloo to look at how it performs in our winters here in Canada. And out of that, they've also developed guidance for the design of buoyant foundations for both new build as well as retrofit. So this is something that will allow a small building to lift up when the floodwater comes in and go back down when it recedes. You're not expected to live in it while it's going on, but hopefully at the end, nothing is damaged and you can go right back to living in your building. Some very large pieces of the puzzle that we addressed are on building in flood-prone areas. So for example, we've come up with guidelines for conducting coastal flood risk assessment and hazard assessment. So that one is coming out shortly as well. And probably the major effort in flooding that we undertook was to work with the Americans who have guidelines on how to build for flood-prone areas. We worked with them, brought that up to Canada with Canadian considerations like ice being one of them being considered. We put together a technical committee and a steering committee who oversaw all that work. And now we're coming out with guidelines for the design of flood-resistant new buildings, as well as improved flood resistance of existing buildings. So that's coming out imminently as well. And the nice thing is, if people would like to keep building in flood-prone areas, this gives them the tools that they need to do so properly. So that will be coming out. Guideline will be available shortly, and we're excited about that one too. And we do get asked quite often, well, what does this mean for the codes? The codes are one of many tools that are out there, but of course everyone thinks, well, we ought to regulate. So what we've done is we spoke with the Canadian Commission on Building and Fire Codes for those who decide what goes in and what goes out of the code. And right now they're considering the role of the National Construction Codes in addressing flooding as well as wildfire. So we're not there yet, but they are having those discussions. So moving from flooding to wildfire, another major guideline that we're quite proud to be putting out soon is a national guide for wildland-urban interface fires. So this guides how you design both the building as well as the surroundings and the community to prevent the spread and damage from wildfire. So this is a wonderful effort, again, put together with a committee right across the country representing different interests like home builders, fire experts. We had Fire Smart on board as well to help develop this guideline. So within it, there's different sections. I've included the table of contents here for those who are interested. One is on identifying the hazard and exposure, including on how we expect that hazard and exposure to change with climate change. Also community resources and design. So how do we plan the wildland-urban interface and access and egress routes? Probably the main section is mitigation in the structure ignition zone. So this is what you can do at the building level, different materials, different strategies for stopping embers from building up in eaves troughs, for example, to help mitigate the fire at the structure level. And then finally, planning and outreach. Of course, we can't forget about the community being integral to our efforts on adaptation. So what's also wonderful about this WUI guide, this Wildland Urban Interface Design Guide, is we worked closely, or we asked infrastructure, or ICLR, the Institute for Catastrophic Loss Reduction and SPA Risk, to conduct an impact analysis. So this gives us a sense of how much is it going to cost us to implement wildland urban interface design right across the country, and what are the benefits from doing so. So they've shown that for new houses, it might cost only $5 per square foot and could save up to $40 per dollar invested. That's quite something. It's a little bit lower for the retrofit side, a little bit more expensive at $10 to $20 per foot, and a return of only about 14 to 1, which is still, I shouldn't say only 14 to 1, that's still very high. But really, for me, the most surprising bit, or the most important piece, is that if you control the vegetation, so the forest, make plans within the community to control the WUI zone, you can reduce those costs by 2/3. That's quite something. So also, if we manage to implement this guide right across the country, we could avoid up to $500 billion in future losses at a cost of only $125 billion, create 20,000 new jobs, save multiple lives, and avoid non-fatal injuries like post-traumatic stress disorder. So it's clear that this is the type of information that's needed right across the board for adaptation efforts, is to help people justify the investment up front, in that look at all the savings that can be achieved. And I think the story is true for many other areas. We just need to do the studies that can help support people adopting this type of guidance. So this is another nice story about the Canadian Electrical Code. So this one started about 4 years ago with a CSA group as well, who housed the Canadian Electrical Code. They ran a series of workshops right across the country. I think it was about 5 different workshops, different places across the country, to engage stakeholders in conversations they'd never had before about how is the climate going to impact our electrical infrastructure? What can we do about it? What are we seeing? What are some of the best practices? So that was all grouped together in the document you see here in the photo, as well as the link there will take you straight to that document if you're interested in it, that summarizes the findings from those workshops. Additionally, we managed to get people together based on those workshops into 5 different groups that then developed 50 proposals for change to the electrical code. So this deals both with the transmission lines in part 1, as well as, part 3, I should say, as well as the electrical equipment in part 1 for the most part. So I'm pleased to say that the latest edition of the Electrical Codes Part 1, that deals with installing and maintaining electrical equipment, is recently published, now has accepted 5 proposals for change to include flooding. This was something that was not considered before, the flood elevation. So now there's requirements for certain equipment to be kept above the flood elevation height, as well as certain requirements for things such as the plugs where you plug in the sump pump. So there's good changes happening afoot, and the rest of the committees, as well as those that deal with distribution and transmission, are currently considering the rest of the proposals as they go through the system. Okay, so now I'm going to talk more specifically about those 5 areas of interest for a climate resilient buildings and core public infrastructure initiative. The first area is buildings. So this particular area is a very big area. As you can imagine, I've already been speaking about climate data, flooding, and wildfire that all have impacts on buildings. So of course, all those guidance documents are very relevant to this area as well. However, we've also been doing work on durability of building materials, including roofing and walls. And one specific project I want to point out in this space is one that we worked on with roofing manufacturers. So when we first went to them and said, hey, we'd like to design roofing more resilient for climate change, how can we help you? And they said, well, if you tell us what the loads are, which is the climate data, then we can design for it. That's not a problem. But one of the biggest gaps is in the installation. How do we know that someone has installed the roof correctly so that we're going to get the right wind performance out of it? So with that in mind, our roofing researchers went about developing a procedure for evaluating in situ performance of the roofing membrane. So this is a little box here you see in the picture that produces different pressures, negative pressures, positive pressures, to test out the roofing membrane itself and see how performing it is and whether it actually meets the specification. And they also, in addition to that, they develop performance requirements for climate resilient low slope membrane roofing systems. So this is a new standard as well, CSA A123.26, that's recently being published. And it goes along as well with a climate roof calculator that helps you identify what the future loads are going to be, future wind loads are going to be, to help you design a climate resilient roof. As well, on the building side, we worked on CSA S478, which is on durability in buildings. This is referenced in the building code, in the appendix of the building code, but it's not used for regulation. So in this instant, we worked with those committees at CSA to make that guideline into a standard. So now the language in it allows you to regulate for durability, which is a first and very unique. So where there's a will to regulate, there's the ability to do so. And now we're working with committees of the building code to see whether we can bring that standard into the main body of the building code. So that's going to involve a lot of discussions over the next few years. We're hoping that it's possible for 2025, but again, we need to work within the system of the building code. Another area we're working on is overheating, understanding how people's bodies respond to hot temperatures, what temperatures, indoor temperatures are going to cause issues, how are communities going to change in terms of urban heat islanding in future climates, and what can we do about it? So not putting an air conditioner in every single building, because that's going to result in increased energy consumption, which is something we want to avoid, but potential measures such as passive measures like shading, ventilation that can be used. So out of that, we're hoping to bring guidance, both as guidance documents, but also to the National Building Code as code change requests. So there's a few updates to the 2020 Building Code, including updated climatic design data for current data, not future yet. In the next edition for the 2025, that's where we're hoping to work with those committees to bring in the future design data. So pivoting from buildings to bridges. Bridges is a nice space in that there's already a code in Canada for bridges. It's the Canadian Highway Bridge Design Code. It covers a whole lot of bridges in this country, not just the big beautiful ones that you see in pictures, but all those overpasses are governed by the Canadian Highway Bridge Design Code. So this is a wonderful place to start. So we had a look at it, looked at where the gaps were, and we worked with the committees to influence what was in the 2019 Canadian Highway Bridge Design Code. And at the end of the day, they came up with provisions for sustainability and resiliency. So really the intent to design in a resilient way. And now we're working with them to develop full provisions on how to design for future climate data for the 2025 Bridge Design Code. Now, if you look at the map on the upper right, this is really one of our success stories in that when we first started with Canadian Highway Bridge Design Code, the 2014 edition, they were still using data from the 70s in some cases. So ice data from the 70s, humidity from the 70s. So if we can't design for the present, how are we going to design for the future? So the first thing we did was update all those maps, all those data that are in the 2019 to bring them up to present day. So that's one of the maps shown here is on ice accretion. So that deals with new bridges primarily. We've also been looking at existing bridges, understanding how they're going to change in a changing climate, how different temperatures will accelerate corrosion, for example, deterioration, change to the service load of those bridges, and coming up with guidance on how to deal with that. Another interesting project is the one shown in the picture below. This is called Bridgital, as they like to call it, and it uses satellites to measure small displacements of bridges. So it can actually measure the changes in the bridge surface due to temperature. So as it stresses and strains, they can actually detect the small displacements. And using that information, they can detect if there's anything strange going on that might warrant an inspection or increased maintenance. So this is something that's in the early stages. We've done a few pilot projects, such as the one shown in the picture of Victoria Bridge in Montreal. But I think one day, once we get there, once we get there, I think one day it would be great to see a constellation of satellites around, well, over Canada to start with, but around the world to monitor some of our most important assets like dams, bridges, major highways, to detect the problems before they really become major issues. So it's something of the future, but I don't think it's that far off. It's something that we're developing now and applying it, and we're working with the UK as well in this area. So something to keep an eye out to see where this technology goes. And the last item on bridges I want to mention is on bridge cables. Our aerospace engineers actually installed a bridge cable measuring device in their wind tunnels to look at the vibrations of cables in wet, icy, and dry conditions. And they actually found that when they're wet or icy, they can produce vibrations that are outside of what those cables were actually designed for. And so this has triggered an update to the guidelines that are used to design those cables. So another success story. So roads is a different area from bridges in that there isn't really a code that governs roads. And you'll see this in a lot of the infrastructure areas. There's guidance documents. There aren't a lot of codes and standards, which makes it a lot harder to figure out where to start. So in this case, our roads experts looked at how Canada's climate's changing. They looked at how that's going to influence the durability of our roads under different conditions, freeze-thaw cycles being one of them, increased temperature being another one that's going to affect how our roads perform. And out of that, they're coming up with guidance for the design of climate resilient roads, as well as they've developed a couple of new tools. So one on asphalt selection, another one on pavement adaptation support. So these tools are preliminary. They've been developed. They're kind of beta versions, but I would invite anyone on this call who's interested in knowing more. Please reach out to us. We'd be happy to demonstrate them, speak with you, talk about maybe having pilot projects with them. That would definitely be of interest to us. So please do reach out. Of course, we're looking to further develop these and get them out there as we move forward. And there's one other item on this one, I almost forgot. We've also been working on water permeability of concrete, so permeable concrete, which is used for drainage in parking lots and things like that to increase or to reduce urban flooding really by using the ground itself to absorb the water. So we've actually developed a standard method to assess the performance of pervious concrete that didn't exist before. In the water wastewater area, another one that doesn't have a whole lot of standards or codes, we started again on stakeholder consultation. We reached out to different groups across the country, held 2 national workshops, and asked, what are the priorities in this area? So first of all, the major priority was stormwater. The thought was, with the changing climate, stormwater is going to see the impacts first. Not to say that water and wastewater aren't important, but they're going to see the impacts likely more on the long term. So a lot of the efforts in this area was focused on the stormwater area. And one thing that came out loud and clear was also, once again, the need to understand the cost benefits to really justify the ability to invest in adaptation projects in the stormwater space. So we undertook a suite, I would say, of projects or of contracts to understand the benefits and the costs associated with stormwater infrastructure, both gray and green, including the costs as well as the legal, the social and indirect costs, and the environmental impacts. So with this information, we are going to be publishing a national guideline on the comprehensive cost benefit of flood prevention infrastructure. So hoping and that addresses really one of the biggest challenges in that space. I already mentioned the climate change adaptation for wastewater treatment plants. That's another important output for the sector, but also that we've been doing some research projects on water distribution as well as wastewater treatment systems. So in terms of water distribution, sorry, I need a drink of water, obviously. So in terms of water distribution, we looked at temperature and precipitation changes and how they impact the capacity of the water system, how it's going to change energy consumption, as well as any impacts of freeze thaw and other temperatures and precipitation on pipe breaks, and also water quality. So how is climate change going to affect water quality and the way we treat our water? On the other side of things, wastewater, they're looking at the temperature and precipitation impacts on conventional wastewater treatment, as well as treatment in lagoons and polishing ponds for remote communities. And finally, looking at how climate change will potentially affect the water quality in receiving aquatic environments. And the final asset area that we looked at is rail. Again, another area, and you'll hear me repeat this a few times, it doesn't have codes or standards, but very keen participants from the Canadian Urban Transit Association. We worked with them to identify what needed to be done. And I think from those discussions, we identified that we needed a lot more understanding of how our transit systems are operating in the current climate, what challenges they're seeing, and how we monitor them and understand what's going on. So out of this, we developed 3 different projects. One of them is the top one here. We worked with the Toronto subway system, the TTC, to instrument the whole subway system, pretty much 40 sites along the Toronto subway, over 120 temperature and humidity monitoring stations, as well as new types of sensors we developed to put on the trains themselves that had GPS coordinates in them to track the trains traveling through the tunnels and stations and record the temperatures as they moved along. So out of that, we're looking at how extreme weather events, hot days in summer affect the comfort in those stations and in those tunnels and in those trains, and then coming up with solutions for what can be done about it. In another area, we also are investigating the impact of freeze-thaw cycles on railway tracks. We actually worked with Via Rail on this one on a series of tracks close to Smith Falls. So if you've ever traveled on the rail line between Ottawa and Toronto, you may have passed over our little station that's measuring the tracks in that location. And here we were looking at understanding how freeze-thaw cycles affect railway tracks in terms of safety, operation, as well as passenger comfort. The reason behind the freeze-thaw cycle project was really that the operators or the transit operators that we met with CUDA had mentioned that it used to be that they would go out and inspect the tracks once in the springtime to see the impact of the thaw and then give the okay, and away they went. But more recently, they're seeing many freeze-thaw cycles every spring and the need to go out more and more to have a look at those tracks and see how they're performing. So this was one of the solutions, is to look at, what is actually going on, what can be done about it, and how does it impact the safety and operation. And then the final one on here, we looked at different technologies to measure the stress and the strain in the rail tracks, including using fiber optics to look at stress and strain. This is all to understand how things such as overheating create stresses, create what I've heard is referred to as sun kinks in the lines that can really slow down the operation of the trains over those tracks. Okay, so those are the 5 different asset areas. As you can see, I know I'm filling you full of information today. There's a whole lot that we've done over the last 5 years, so lots to talk about. But as we get to the end, please do feel free to reach out to me and others to ask questions. Happy to put you in touch with anyone on any of these projects. So this area on life cycle environmental assessment is very, very important to the project as well. As mentioned, there's no point in adapting if we're not considering mitigation. I think the point is we want to reduce greenhouse gases while making our environment more resilient, and that's the sweet spot. So we've been working on developing guidelines of how to do life cycle environmental assessment for the adaptation of buildings and public infrastructure to climate change. So this looks at understanding how climate change is going to affect the lifespan of our equipment, the need for maintenance, and looking at what can be done at the start. So there's been case studies as well done under this umbrella on roads, bridges, buildings, as well as stormwater infrastructure, all leading up to the suggestion that, or really the proof that if we invest properly at the start, it might be more expensive, it might have more greenhouse gases at the start, but along the lifespan of the asset, we're going to see less maintenance needs and less costs the long term, as well as less greenhouse gases emitted because we didn't have to repair it as many times and maintain it as many times. So this type of work is equally as important as the cost benefit analysis, is really what are the benefits to greenhouse gases of investing in adaptation at the start. And the final item on this slide is also very, very important. It's Canadian Life Cycle Inventory Database. Now, this isn't something we did under the climate resiliency work. It's actually sort of a spin-off. It's something we identified as a gap when we first started the work and said we really need a life cycle inventory database in this country to understand the embodied greenhouse gases in the materials we're using for construction so we can do proper life cycle assessment. So this started, I believe, about 2 years ago, where we triggered the development of this LCI database under a new project at NRC called Low Carbon Assets Through Life Cycle Assessment Initiative, or LCA squared. So when this is done, it's going to be a database that's unbiased of materials that are used in Canadian construction and can be used then to advise LCA decisions. Okay, so that brings me to the end of some of the bits and pieces that we've accomplished. It's wonderful to be able to share this information with you. And I think I wanted to conclude today just by talking about, where do we go from here? And I think we need to pause for a minute and look at where here is. And this is where I put this slide in to talk about NRC's capabilities. So with all this work, trying to move the bar forward, we've also ended up developing our own expertise at NRC and across Canada. So first of all, now we have a lot of expertise in understanding both how the climate's going to change, but how our infrastructure, our buildings, our roads, our water, wastewater, bridges, and rail are going to respond to it. So this is expertise we didn't have before. We had some of it in a few of the areas, but definitely it's growing. It's also a national network of expertise. It's not just us. We've been working closely with others, as I mentioned, over 200 different organizations and persons across Canada with different backgrounds. And we're really positioned well to keep going on work in all these different areas to leverage this network to help build more resiliency in our assets in Canada. We also, based on the work that was done by Environment Canada, we have a good sense of what future Canadian climate scenarios look like. And in addition to the data set that we've published, we also have the ability to use the data and from those model runs to model different assets like buildings, bridges, roads in a changing climate in different climate scenarios. And we can use that to look at durability, energy performance, comfort aspects. So it's really a vast resource that we can now use to understand what the future is going to look like. We've also have many full-scale facilities for performance assessment. We had some before where we could blow wind-driven rain at buildings, look at fire conditions of whole wall assemblies. There's a few new ones I wanted to point out. On the right-hand side, on the bottom, we have something that our researchers refer to quite kindly as the baby dragon. I like this one. It's an ember generator. Embers are one of the main causes of wildfire spread, aside from radiation being another one. So the ember generator is meant to spew embers like a dragon and allow you to test different building materials and assemblies. And the top picture here, they don't call it this, but I call it this. I call it the Stargate because it looks like a Stargate. It's about the same size as one. But this is our facility to test full-scale bridge cables. So it goes in the wind tunnel by the airport here in Ottawa, and they blow wind across it. And there's a cable suspended in the middle of that big circle, full-scale bridge cable, that they can also spray water on. And they can look at the vibration of that cable. And this way they can look at different designs, cable designs, to help mitigate vibration and look at which ones will best perform on bridge-stayed, or sorry, cable-stayed bridges. So another area as well we've developed capabilities in is field trials. You saw the major field trial that's being undertaken with TTC in Toronto of the subway. So this is just one example of areas that we can go out, have a look at what's going on, and look at solutions on adaptation. So where do we go from here? So I'm pleased to tell you that we're not stopping. We're right now in the midst of talking with Infrastructure Canada about our next 5 years. It's not signed off yet, but all signs are pointing to that we get to keep going, and I think that's a wonderful thing. So a big thank you to Infrastructure Canada for letting us keep going in this area. So in that, we've identified basically 5 different ways that we can improve the resiliency in Canada. So the first one is generating knowledge, and I think this is something we did very effectively under the first phase. We generated knowledge, especially on climate data, on those 5 different asset areas, but there's still gaps. There's still gaps in those asset areas, but there's also larger gaps in areas we didn't address. For example, nature-based solutions, natural infrastructure for coastal, riverine, urban flooding, as well as reducing urban heat islanding. There's also gaps on, more specifically on flooding infrastructure, so dams and dikes and floodways, to understand how they're changing in a changing climate and what can be done about it. This was something that was brought up quite often in the first phase. What about dams? So I'm happy to say that I'm hoping in the next phase we're going to pivot towards looking more closely at that flooding infrastructure question. So the second picture here is supporting evidence-based decision making. So what this means is we want to take the information generated in the first phase and integrate it into the tools that communities, that professionals need. So can we work with others who have those tools to integrate the climate considerations into them? Can we develop new tools where there's gaps? So it's really looking at how do we get this information into the hands of people who can use it. The third area is enabling regulation. So where it makes sense to regulate, we want to make sure that we have the information to support those codes committees in enabling that regulation. So following through on the changes that are currently underway for the Canadian Electrical Code, our code change requests to the building code, as well as following through on the bits and pieces for the Canadian Highway Bridge Design Code. We're also interested in looking at where it makes sense to move some of our guidance documents through to standardization. The fourth area is advancing technical solutions. So can we build upon work such as Bridgetall to different applications? We can move it to dams, for example, have a look at whether satellite monitoring of dams makes sense. Other technical solutions as well, trying to understand how different building materials perform in future climates, different building assemblies, helping to support really Canadian companies and Canadian enterprises on developing and advancing those technical solutions to help us meet our adaptation needs. And the final area, I think, is maybe the ultimate goal really, is building capacity in Canada and abroad. So how do we make sure that Canadians have everything they need to adapt? So in some cases, this might mean working closely with some of those areas we haven't yet. I'd like to see more work with remote communities, Indigenous communities, more specifically to meet those communities' needs and respond to those needs. In terms of the bigger picture, of course, we're looking to partner very closely with our international colleagues to share best practices, help others advance. Chad was mentioning the work we're doing on building codes we're working with the UK, the United States, Australia. Really, they're inspired by what we've done with the climate data piece for the building code and looking to follow in our footsteps in a number of ways. So looking at how we can work internationally to share our best practices and help everyone advance. So that brings me to the end of my rather jam-packed presentation, I must say. But I'd like to leave you with 3 links. The first one is to the main link to our project on climate resilient buildings and core public infrastructure. And this link is where you will find all those documents posted once they become available. And as I say, many of them have to be translated or edited at this point. So in the coming months, we expect more things to appear on that website. The second one is the Canadian Centre for Climate Services. They do all things climate change with Environment and Climate Change Canada. There as well, we're looking to link a lot of our outputs through to CCCS. So please keep an eye out there. They also have a portal now for standards related to climate change adaptation. So ours, as well as some standards that were developed by others, including the Standards Council of Canada. And of course, the final one there is my email address. So if you have any questions, want me to put you in touch with any researchers, please feel free to reach out to my email address.
Oh, thanks very much, Marianne. That was excellent. Thanks so much, Chad, too, for those opening remarks. So we do have about half an hour now for question and answers. We've received some really fantastic comments as well in the chat box. I'm not going to read those, but I do encourage you to read through them as some really fantastic links that people have posted. So I will start off with some questions that have been coming in, if that's okay, Chad and Marianne. So one question from Ken is asking if the flooding analysis feeding into the Canadian dam standard for dikes and dams, if it is feeding into the Canadian Dam Standard?
So on, it isn't yet. It could be. So right now, sorry, I have a small child here. um, so so in terms of the Canadian Dam Standard, that's something, discussions that are underway with CSA. We're coordinating closely with CSA as well. So certainly we'll be looking to make those linkages as we move forward. So right now we're coming out with those IDF curves shortly. So the hope is then to link that through to standards and areas that'll be used.
Yeah.
Okay, great. Do you have anything to add, Chad?
No, actually, it captures it well. I was just going to say I can take the next question if there's one that's particularly for me, if it's helpful.
Okay, it's okay. Sure. I've got my kid's okay.
Okay, well,
I can take one.
Okay, that's great.
I was going to say, Marianne, that's a very 2021 comment. I have a small child here.
I do.
Sharon Lamb is asking if there are temperature and humidity monitoring data of TTC stations publicly available or if they can be shared. However, I do think somebody answered that.
Fiona might have. Fiona has been running this project for the last year. She's done a wonderful job. So if she answered it, that's great.
Right, that makes sense.
I think
okay.
Right now that if she did, but just to mention on that note that we're working on that data now because it's one of the projects that's slightly delayed because we weren't able to go on site because of COVID. So that one's going to take a little bit longer to come out. I'm not sure if the actual data itself will be publicly available, but the analysis and the conclusions and the findings that are useful to others will become available.
Okay, fantastic. Others are interested in these sort of coming soon reports and databases and whether there's any kind of newsletter or RSS feed that they could sign up for to get notified.
I would say we don't have one, but it's something we could look at. If there's specific items that you saw today that you're interested in, you can send me a message and we can make sure that you're notified when they do come out. The other thing is just to keep an eye on our website as well as those become available.
Okay. Nick says 5 years seems a long time to wait for the proposed climate change provisions in the 2025 building code. Considering we are in a climate emergency and are already experiencing climate impacts, is there any desire or possibility to advance the publication of those or perhaps add the climate change provisions as an update to the 2020 code?
I'd like to
I've just been working with them. You want to help with this one, Chad? Do you want me to go first?
I'll give it a shot. Maybe I'll start. So it's a very insightful point. I appreciate the question. And I think that it's one that we struggle with a little bit because there have been, sort of, as I said, leaps and bounds, recent development of new knowledge in this regard. To some degree, the future is not yet written. So we have commitments right now to initiate. Our minister launched a national infrastructure assessment, and there's a public discussion paper out to seek your engagement on, including a green and inclusive community buildings initiative we're actually seeking input on. So there's that NIA, or National Infrastructure Assessment, is an important piece for this dialogue, along with the commitment to develop a national adaptation strategy for Canada. So I just think that it's true that there's a 5-year cycle in general for the codes. There's a few examples, I think, with the electrical code in the past where there was an accelerated, Dwayne Torrey online might know that better than me, but there have been examples in the past where some things have been accelerated. But I just wanted to say that there seems to be a strong commitment right now to take action and recognize certainly the sort of the cost savings that can be achieved. I would say Infrastructure Canada is engaging in its very senior officials levels with provincial and territorial counterparts explicitly to discuss resilience. And so I wonder if there's anything you want to add to that, Marianne.
Yeah, I think we have to recognize that the codes is one of many tools, and I think historically it's always been used kind of to bring up the back end. That being said, it can be used as a tool to try to accelerate things, but there's so many other tools as well we need to consider, because now that we have these guidance documents out, they of course can be used across the board. Incentive programs can help drive change. I think there's a lot that can be done before a code change will come out by 2025. and we have all the tools to help us move things forward. The codes are also in place for a reason to consider all those different consequences, like what is the consequence of doing this work on energy efficiency in buildings. So there's, or what is the consequence on the cost or the consequence to the home builder. So there's a lot of different things that need to be considered before something becomes regulation. So that's the reason that the codes process exists, and why it can take quite a while to get there. But I think it does speak to the fact that there's interest by the provinces and territories, there's interest by the Canadian Commission on Building and Fire Codes to look at what can be done for climate change adaptation, and those discussions are happening, but they're not fast. And historically, the codes move slowly so that they don't end up in a situation where they make a mistake. So I think we have to recognize that. But we also have to recognize that there's so many other tools available to help make these changes in the coming years.
I would add a tiny word, is that at Infrastructure Canada, we have purpose-driven funding to support climate outcomes or climate objectives. And so that's another means for considering how do we get the latest and best guidance out there into play, including as well our funding requirements, such as our climate lens. Thanks. I'll be happy to turn to another question.
Okay, from Joanna, how do you see natural infrastructure fitting into the climate resilient built environment initiative? The combination of built natural approaches going forward seems an area we need more support.
Do you want to go first on that one, Chad?
Sure. So, well, we've heard a lot of calls for the green recovery, whether it's from a task force for resilient recovery, a green budget coalition, numerous voices from across Canada, many organizations saying that natural infrastructure is a key component, given the co-benefits that come with natural use of sort of natural infrastructure and green space, be they sort of mental health and recreational benefits, as well as delivering true kind of infrastructure services, be it in terms of water filtration and a wetland and stormwater. So there's a lot of interest out there that's being heard by the government. The Prime Minister's supplemental ministerial mandate letter for our minister on January 15th directed our minister to pursue more work on natural infrastructure. We're at I think a embryonic time in terms of getting into the details of where to from going forward from where we are on natural infrastructure, but there's a lot of interest, and Canada as a country was supporting the Nature-Based Solutions Action Track under the Global Commission on Adaptation, and there was a 2 years of work on that recently was sort of summarized in an online global forum you can see in December. So pleased to answer kind of more offline questions about that, but I would just say there's a thirst and there's a logic to pursuing it. We know that it's useful for water, particularly as an interface of climate impacts and infrastructure. So whether that's potable water, wastewater, stormwater, infiltration, we also know that urban tree canopy can help to address, or green roofs can help address heat waves. So those are a few little flavors of things to be considered. Over to you, Marianne.
Yeah, absolutely. I think we recognize that more needs to be done on natural infrastructure and nature-based solutions, and we'd like to look more into supporting that. So I think we're right now exploring what can be done and what areas to work in. So Joanna, if you do have any suggestions, please do feel free to reach out to us and let us know what you think is needed. I think because right now we're at that phase where we're collecting ideas, collecting the needs so that we can really design the next phase.
You know, the FCM's put online a new portal for all information about nature-based solutions and natural infrastructure, along with the Green Infrastructure Ontario Coalition's new portal online as well. I see there's a thirst for on-the-ground action in the comments, so just wanted to add that in.
Wonderful. So I have a bit of two-part question. The first one from Erica is that I've heard Marianne is working on guides for First Nation infrastructure on reserves. Let's actually just start with that one.
Sure. Yes, so there was an effort with the First Nations National Building Officials Association on developing guidance for residential buildings in small and remote and indigenous regions. So this considers things like permafrost and other pieces. So they've been developing the data, gathering the data, and developing these really guidance documents in consultation with the First Nations Building Official Association. So that's, I think the timeline for that one is about another year before that comes through.
Okay, wonderful. So also Ken from Kashechewan First Nation is bringing up the work between Indigenous Services Canada in partnership with Kashechewan. They're working towards a planning phase of relocating the community to a new remote greenfield site. And as part of this work, pending its progress and availability of budget, Kashechewan will be constructing a 30-kilometer road with various water crossings along with all the necessary infrastructure at their new town. So Ken's curious to know if and how there can be a whole of government approach to supporting this activity, with NRC providing key advice and guidance on how we plan, design, and build for resilience and sustainability.
So I just think you can help with I can help with the science side and say that we're looking for as well in the next phase of identifying where those needs are of Indigenous communities and small communities, where we can help apply the science and answer the questions that are needed and work with them to integrate Indigenous knowledge with the knowledge we've developed in the first phase to come up with solutions that are appropriate and needed. But I think in terms of the whole government approach, perhaps Chad can comment on that one.
Sure. Again, on January 15th, all of the federal ministers, or the majority, received new supplemental ministerial mandate letters from the Prime Minister. And the ministers at Environment and Climate Change Canada and of the Treasury Board were directed to develop a climate lens for all federal decision-making. In addition to Natural Resources Canada, Environment Climate Change Canada, Infrastructure Canada, and Public Safety, those four are being told to develop a national adaptation strategy. I think I'd be pleased kind of to receive or follow up offline to further this discussion, but there are do seem to be efforts in my mind that respond to the question about whole of government approaches to supporting this activity, and the national risk profile work that's led by Public Safety Canada, along with the flood mapping that's basically co-led with Public Safety, NRCan, and Environment. These are all pieces of the puzzle that can be helpful. I'd say that there's no one recognized portal or definition, but I think the best answer to that question lies in between the National Adaptation Strategy, a federal climate lens, different than Infrastructure Canada's climate lens, and the National Risk Profile. I'm pleased to help respond later offline. Thanks.
Thanks, Chad. I don't think I brought this question up from Lisa. How do you think municipalities, big cities can and should work with NRCC to apply the new guidance to new development in their locales?
Yeah, I think certainly they're welcome to reach out to us with any questions on that. I think we've engaged with a number of them in the development of some of these guidance documents. For example, on the flooding one, we were working closely with like Montreal and Calgary and other cities that have seen flooding on the advisory board, so they're quite familiar with a lot of the work that was done to develop those guidance documents. And the same thing on the wildfire side as well. I think as we move forward too, we'd be interested in hearing from those communities as to what their adaptation plans are. If we go further on any of these documents or develop new documents to address those needs, whether these communities would be interested in being integrated onto an advisory board for different areas. So certainly we'd be interested in hearing from them, both looking at their challenges if they're looking to apply these guidance and see challenges in doing so, but also in looking at where we need to go next.
Okay, good. So we still have some time for questions. So I'm going to offer up the option to ask a question or say a comment over your microphone. So if you know you have a microphone on your device, raise your hand. There's a hand icon at the top bar of the screen, and I will unmute you for you. Okay, thanks. Otherwise, you can still enter your questions in the chat box. In the meantime, we did get some questions that came through in um, the registration page, sorry. One of them is that, I think we did touch on the impacts already. Okay, so this person asks, I see there are guidelines for work on wildfire in a WI and flood mitigation for buildings, but are there plans to integrate these provisions into codes? I think you might have touched on this in your presentation, though, Marianne.
And I think as well, some of it, we have to look as well at the guidelines tend to go further than what the codes ever could. So if you look, say, for instance, at the wildfire guideline, it has pieces on community design or landscape maintenance and things that wouldn't necessarily be covered by something like a building code. So in a number of cases, the guidelines are going to be more holistic than potentially what gets submitted as a code change request to the code system. So I think we have to recognize that as well, that codes have a role to play, but the guidelines can actually, in some cases, cover a lot more than the codes might as well.
Okay, thanks. We're still welcoming more questions. You are welcome to raise your hand and ask it over your microphone if you'd like. Elizabeth asks, Chad, I'm also interested in following the discussion of whole community approaches to improvements of infrastructure, particularly related to flooding and integrating traditional knowledge. Please, could you keep me in the loop on this conversation?
Okay, thanks. There's an awful lot for many of us to try to be kept in the loop these days, and I appreciate the interest and the importance of these matters. So we have a sub-page on our Infrastructure Canada webpage on this project as a whole that Marianne has the link to kindly on slide 28 of the presentation. There's there's a link on that page to everything we've done on flooding that has been done by the NRC on this project on flooding. I think that would probably be the best place for us to keep that updated for broadest collective benefit to all people. So that would be my response, is that we'll work to make sure that that page is updated so that everybody can kind of be kept in the loop as appropriate.
Great. Give some others opportunity to enter their questions. Yes, Thomas. So I'll distribute the slides via email, and they'll be posted onto a link on Climate Risk Institute's website. I'll just change the slide here to show you. So if you're interested in previous or upcoming webinars and recordings, they're all posted on that link, the Climate Risk Institute's website under platform webinars. You can also access Canada's Climate Change Adaptation Platform web pages for information on their platform or working groups and products. The link is there in English and French. And also any other questions you can address to the Adaptation Platform or, of course, to myself. Suzanne, you have my email from this morning. So give just a couple more minutes for people to enter any questions. Okay. Well, if you didn't have time for your question to be answered or you're still thinking about it, you're welcome to email me, Suzanne. I'll connect you with the presenters. Or there's also Marianne's email posted on the page here. So with that, I'd like to give it a really big thanks to you, Chad and Marianne. What a wonderful conversation and really informative material. So thanks so much for your time and for doing this. And hope you have a great rest of your day. Any other kind of sign off questions or comments? Sorry.
I think just a big thank you to everyone for listening to me today and coming out and seeing what we're up to. And I really hope that this inspires you to learn more about some of these tools that are coming out, to use them, to connect people to this work, and also to see how you can be engaged as we move this important area forward. So thank you.
I would agree. That would be my kind of final similar comment. Just that I really encourage. Well, I'm very thankful that people came out to today's call and had it such a high level of interest, and very hopeful that the folks on this call will take action in their own communities and in their own spheres of influence to ensure that we're planning for a future that seems quite different in some respects than the past. I'm really thankful and hopeful people can engage, make those changes that we need to pursue. Thanks.
Excellent. Okay. Thanks, everyone. Take care. Bye bye.
Bye.